Hi everyone and welcome to this video where we'll be discussing the sine rule. The sine rule is a rule that is not specifically for right-angled triangles like the previous parts of trigonometry that we've been covering together. For the sine rule, the way that we're going to label our triangle is slightly different. What we're going to do is use capital letters for the angles, and opposite those angles we're going to use the lowercase letter to label the side. So opposite A will be little a, opposite B will be little b, and opposite C will be small c. The sine rule is very simple to remember. It is a ratio between the sine of the angle and the opposite side to that angle. So writing it out, it looks something like this. The ratio between sine of A and the opposite side little a is the same as sine of B, the sine of the angle B, divided by little b, or the side length b, and this is also equal to sine of C divided by its opposite side, little c. So this here is what we call the sine rule. And if you're pretty confident with fractions, maybe you've already noticed that we could rewrite this with everything just the other way round, with the side lengths on top and sine of the angle on the bottom. So it would look something like this. Now both of these are perfectly fine. However, when we're using these equations, we're never going to use all three sections. We can't have two equal signs, and we don't know how to solve something like that. So we're going to pick, in particular, two of these fractions. Let's pick out A and sine A, B and sine B as our example. So in what situation would we require this equation here? Well, we would need, first of all, our angle A, and the side length A, and the side length B, and the angle B. And it creates this situation where the sides are opposite the angles, and the side is opposite the angle. If we have two pairs of quantities that are linked together as such, then we're going to need to use the sine rule. Of course, we're always going to have one of these left as an unknown variable, so either a side could be unknown, or an angle could be unknown. And we'll have a look at that in more detail when we're talking through some of our examples. Let's look at the situation where we have a missing length. The question is asking us to find the length of BC. I have two angles and one side given to me. Let's see how those relate to each other. So I'm looking for BC, which I can label lowercase a because it is in fact opposite my uppercase angle A. Now the two remaining quantities that I have are this angle 41 and the opposite side 18. So those are opposite each other as well. And whenever you see this shape here with the angle opposite a side, you know you have to use the sine rule. The way I like to set up the equation is to place the unknown variable on the top. It makes it a lot easier to solve. So the unknown quantity in this question is our side lengths. So let's write out the sine rule with the side lengths as the numerator. Once I've got this formula down, I can now start to plug in the variables that I know. So I keep a as my unknown variable. I replace the uppercase A with the angle 113. I know that lowercase b is 18 and uppercase B is 41 degrees. Now what I need to do is to multiply both sides of this equation by the denominator on the left, so sine of 113. I should also add in brackets here to make sure we don't forget to close those brackets after our sine. Let's do that multiplication then. So A is equal to 18 over sine 41, and we're going to multiply that side by sine of 113. So of course that multiplication of sine 113 on the left will just cancel with the denominator, leaving us with A. Once we've got it to this stage, we can just place that into our calculator. And if we solve that, we find that A is 25.3 meters. So you can see that in my diagram I have these arrows that are crossing each other. Whenever you're able to draw this situation with variables that you know and your unknown variable, remember you can only have one unknown variable, but if you can draw this situation, then the sine rule is what you would need to use to solve the question. And now let's look at the situation where we have a missing angle in our triangle. To start the question, we're going to see if we can draw that cross arrow shape inside of that triangle. So 28 corresponds to the side length 8, so we can draw ourselves an arrow. And the side length 12 is opposite the angle x, so those are related, as well. Those are opposite each other. Okay, so I've got this cross arrows situation. I know it's the sine rule that I'm going to need, and I can see that the unknown variable is the angle. So I'm going to write the sine rule with sine of the angles on top, sine of the angles as the numerator, of course. So let's get that down. Once we've got that down, then let's plug in the variables that we know already. Now that I've got that down, it's time to rearrange this equation to get x as the subject. I can multiply both sides of this equation by 12. And now I can apply inverse of sine to both sides of the equation. Applying that on the left will just leave us with x by itself, and I'm going to need this big bracket with inverse sine on the outside and whatever was in that right-hand side on the inside. So at this stage, I can just place the right-hand side of this equation into our calculator. However, when we're doing inverse sine of both sides of an equation and we're dealing with triangles that aren't 90-degree right-angle triangles, it's important to first work out the value inside the bracket of inverse sine. We find that the inverse of sine takes the value 0.7042. I've kept a few significant figures for this step. At this stage, if you are familiar with the graph of sine, I recommend that you do a quick sketch of the graph between 0 and 180 degrees. This is my attempt at a quick sketch here, so let's put on the y value of 0.7042. That is going to look like a horizontal line on the graph like this. We can see that there are two intersection points between the value of y is 0.7042 and the sine graph itself. So this first coordinate here is what your calculator will work out if you just place this right-hand side into the calculator. However, we cannot forget about this point here. So you can see that the left-hand point has a value less than 90. This is an acute angle. The right-hand point has a value greater than 90 but smaller than 180, so this is an obtuse angle. Now this angle could then either be obtuse or acute, and it's up to you to decide which one of these angles you're about to take. If we look at our diagram, we can see that x is clearly an obtuse angle. It is greater than 90 degrees. So we would have to work out the second value and not the first value. So whenever you're using the sine rule and you're looking for that angle, remember to do a quick sketch of the sine graph between 0 and 180 degrees. Use a horizontal line to label what is on the inside of your inverse sine function. Find those two intersection points, and what we're going to do next is solve this inverse sine function in our calculator to find the first value. The value that we get is x is 44.77. We can see that our angle on the diagram is much bigger than 44.77. So we are going to use a little bit of symmetry on the graph to help us find the next one. We can see that from 0 to this point, it must be 44.77. However, our graph is symmetrical about 90 degrees. So from 180 degrees, we must come in 44.77. So what we will always be doing is 180 degrees minus our acute angle in order to find the obtuse angle if we're using sine. And so we have found our obtuse angle 135.23 using the sine graph. I recommend remembering the sine graph and how to use it to solve these equations. This is helpful because there is another topic at GCSE that is all about the trigonometric graphs, so remembering them and being able to draw them is very helpful. However, if you find that tricky, you can just remember to use 180 minus the acute angle that your calculator finds. That way you will always be able to find the obtuse angle as well. Let's look at this example together. Here we have a missing side, and we are also able to set up the question with an angle opposite a side and an angle opposite a side, where we know 3 of these numbers and are missing 1, which is our unknown variable x. Once we've got these cross arrows in our triangle, we know that we're going to use the sine rule. We see that the unknown variable is a side length, so let's write down the sine rule with the side lengths on top. Once we've got that down, it's time to plug in the variables that we already know. So it's important to note that this triangle was not labelled with A, B, and C. As long as we remember that the opposite side to the angle should correspond to the same letter, then we can just use the formula without labelling anything on the diagram. Now we've got that down, it's time to multiply both sides of the equation by sine of 55. We can place the right-hand side of this into the calculator, which works out to be 5.19. Let's look at an example where we're asked to find the missing angle. In this case, we're asked to find the missing angle ABC, so let's label that on our diagram. I'm just going to use capital letter B for this missing angle here. We can see that that corresponds to the opposite side, 128, and the angle 52 corresponds to its opposite side, 158. We can see that we're after a missing angle, so let's write down our sine rule with the sine of the angle on the top. Now let's plug in what we know. We can now multiply both sides by 128. Once we've done that, it's now time to do the inverse of sine of both sides of this equation. Now I can just place the left-hand side of this equation into my calculator and solve for b. I can just do that because I know that ABC is an acute angle, and the calculator is always going to give me the acute angle in this situation, giving me my final answer, 39.7 degrees. Let's have a look at this example here. We're given some information in the question, where the length AB is 40, the length BC is 32, and we're also given the angle BAC is 37. The question also gives us a hint that there are two possible values of the angle ACB. I would suggest having a go at drawing this triangle, see what you can come up with. So here is my attempt at drawing this diagram. You can see that the length AB is slightly longer than the length BC, and we've got this acute angle BAC in the bottom left here. We can also see that the two possible values of ACB are firstly an acute angle here and an obtuse angle here. The two triangles that I have created both satisfy the conditions given in the question. We have this triangle here, and we also have the larger triangle here. To solve this question, we can see that we have the angle opposite a side, with 40 being opposite our unknown angle ACB, and we also have this angle A being opposite the side length BC, which we know. So we've got this idea of a cross arrow inside of the triangle. We know we're going to need to use the sine rule. I'm just going to focus on this left-hand triangle for now, because we'll see that actually, just by using the sine rule, we should be able to get both the acute and the obtuse solutions. We're trying to find the angle, so let's start by writing down the sine rule with the sine of the angles on the top. Let's start by plugging in the information that we know. If you're wondering where I got little a as 32 from, well, we can see that this side length is the same as this side length, because this one on the right is 32. CB here should also be 32. Let's times both sides by 40 and do the inverse of sine on both sides. Now at this stage, because I know that the two solutions include an obtuse angle and an acute angle, I'm going to work out what is inside the bracket of inverse sine first. Once we've done that, we can do our little sketch. I can see that the sine graph intersects with the line y equals 0.7523 at two places. Placing this inverse sine of 0.7523 into the calculator will find us the acute angle. We find the acute angle is 48.8 degrees. I can now use 180 degrees minus the acute angle, as I described before, to find the obtuse angle. We find that the obtuse angle is 131.2 degrees. So we found both values, one acute, one obtuse, the two possible values for the angle ACB. Thank you for watching this video. I'm glad you've made it all the way to the end. If you have any questions about the video, remember you can leave them down in the comment section below. Please like and subscribe if you enjoyed it, and I will see you in the next video.